Hi guys, welcome back. Today we're skipping ahead a little bit, so we're working on page 227 to begin with. And on 227 you will see that Max is shipping a present to his grandmother. Nice, Max. Okay, and in this lesson we're going to start talking about dependent and independent variables. Dependent variable is something that changes depending on something else, and vice versa. We'll talk more about it as we get started. So for this one, we're thinking about what are some factors that will affect the weight of the box. Here's Max's present for his grandma. What could be going on with this box that would contribute to the weight of it? Think of at least 3 things and list them here. And then over here, how might the size of the box and the contents of the box affect the weight of the box? Just think about that for a minute and write your answers. Okay, pause and come back when you're done. Well, the size of the box is going to affect it, right? The bigger the box, the heavier. What it's made of. If it's made out of wood, it's going to be heavier than if it's made out of cardboard. And the contents in the box. If he's shipping his grandma barbells, that's probably going to be heavier than if he's shipping his grandma some knitting needles, right? Okay, and then how might the size of the box and the contents of the box affects the weight? Let's just a little more detail. Larger box equals more weight. The heavier the items in the box, the heavier the box. We kind of talked about that already. Okay. And then focus on math practices, model with math. Describe another situation in which changing one factor results in changing another factor. So for example, if you have a math problem that's about a square, and you say, well, one of the sides is 7 centimeters, that's going to affect the size of the whole square. That means the perimeter of the square will be 28. But if you change the length of the side and say that it's 10 centimeters, that changes the perimeter, right? So the length of a side affects the distance around the entire square. Okay, let's take a look at the next page. Here we have some fresh picked apples. And dependent and independent variables again. An orchard sells apples by the pound. Each day, P is the pounds of apples that are sold, and the amount of money taken in, M, is recorded. Which variable, P or M, depends on the other variable? So let's think about this. We've got pounds of apples, and we've got the amount of money made selling the apples. So which would you say was dependent on the other? You'd sell more apples if you made more money, or you'd make more money if you sold more apples? The way you'd say it was that if you sold more pounds of apples, you would make more money. So that means that the M is the dependent variable. The money made depends on the number of pounds of apples. Okay? So this is just explaining that there. Dependent variable changes in response to another variable. An independent variable causes the dependent variable to change. Okay? Try it. A baker used a certain number of cups of butter. No, he didn't. He used a certain number of cups of batter. He might have had butter in his batter, but really we're talking about batter. B, to make pancakes. Which variable, P for pancakes or B for batter, is the dependent variable? Think about that. Batter or pancakes? Well, if you have more batter, then you're able to make more pancakes. So if you made more pancakes, it wouldn't increase the amount of batter. But if you increase the amount of batter, then you're able to make more pancakes. So the dependent variable in this case is P for pancakes. It's dependent on how much B, batter, you have. Okay? Convince me! If the baker doubles the number of cups of batter used, B, what would you expect to happen to the number of pancakes made? Well, you'd expect it to double, right? Twice as much batter, twice as many pancakes. Okay, let's look at page 229. Here's another example. So in this case, we have a bike shop. Let's look at the graphic here. Joe and Sons, bike rental prices. So we've got two different types of bikes, and we've got a price per day rate and a price per week rate. Notice that the beach cruisers are cheaper than the mountain bikes, and that's true of the weekly rate also. Now, step 1, identify the variables involved in the cost of a rental. Okay, beach cruiser B, mountain bike M, length of rental, price per day, price per week, and total rental cost. We've got all of those things to think about. Which of those things, those are all variables involved in the cost of the rental. Now, determine whether the variables are independent or dependent. So the beach cruiser, the cost would be dependent on the rate per day or per week. The mountain bike, well, that depends on the rate per day or week also. The length of the rental, this is independent and causes the total rental cost to change. So the length of the rental is just something you're going to decide. And then it will affect the cost, because if you decide you're going to rent it for a week, it will cost a certain amount. If you decide it's only a day or 2 days or whatever, that will dictate what the total cost is. Price per day, also independent, and because it doesn't change, right? The price per day for a beach cruiser is $18. The price per day for a mountain bike is $30. That doesn't change based on anything else. And then the price per week, W, it's also independent in the same way that the price per day is. This doesn't change depending on anything. The price per week is always either going to be $50 or $90. And then the total rental cost, T. This is dependent, and it's dependent on a few things, right? It's dependent on what kind of bike you're going to rent and how long you're going to rent it for. Making sense? Just keep letting the idea brew. Try it. Jenna wants to rent a mountain bike by the week. Identify the independent variables that affect the total rental cost. Okay, so she said a mountain bike and by the week. So let's look up here. We've got mountain bike, $90 per week. So identify the independent variables that affect the total cost. Independent is the price per week. That's not going to change. And then the type of bike, she said mountain bike, that's going to be dependent. Okay? All right. Key concept. Pay attention. A dependent variable changes in response to another variable called an independent variable. Okay. An independent variable causes the change in a dependent variable, and it is independent because its value is not affected by the other variables. Okay, the distance a car travels, we'll call that D. It's dependent on the speed, S, at which it travels, right? If you're going 90 miles an hour, you are going to travel a farther distance than if you went 5 miles an hour. The speed is the independent variable and the distance is the dependent variable. The speed is the speed. 90 miles an hour is 90 miles an hour. Or 5 miles an hour is 5 miles an hour. But how far you travel is going to be dependent on that speed. Okay. Let's take a look at page 230. What is the essential question here? what does it mean for one variable to be dependent on another variable? See if you can put that in your own words. Then, number 2, Jake and Viola record the number of miles M they bike to help track the number of calories C they burn in an hour. So here's the question. Viola says the number of calories they burn is the dependent variable. Do you agree? Is the number of calories burned dependent on the number of miles they bike? What do you think? Number 3, in the biking problem above, identify at least one other independent variable that could affect the dependent variable. Okay, so figure out what that dependent variable is and then think what else could affect that besides the number of miles. Okay, do those and start the video again when you're ready to check your answers. Zoom. Okay. So a dependent variable changes depending on the independent variable. Use the independent variable to determine the dependent variable. That's how I chose to express it. Now, is Viola right? Yes, she is. Depends on the miles, the number of miles they bike. So you're going to burn more calories if you travel more miles. Now, for this one, I was trying to think of another independent variable. So the speed. If they bike really fast, they will burn more calories than if they bike really slow. So that's another independent variable. Okay? All right, let's look at this column here. I'll read these and then you can pause the video, solve them, and come back and check your answers. Identify the independent variable and the dependent variable. So what I did when I was solving these is I wrote D equals and I equals, and then I just wrote the variable. So the amount of money M earned if T raffle tickets are sold. So which one of those is the dependent variable and which one of those is the independent variable? Let's see, the money earned is going to change depending on how many raffle tickets are sold. So M is going to be the dependent variable and T is going to be the independent variable because that's the order that they go in, right? You don't say, well, I sold 10 raffle tickets because I earned $20. You say, I earned $20 because I sold 10 raffle tickets. Okay? So go ahead and read each of these and decide which is the dependent variable and which is the independent variable. All right, let's check our answers. So for number 5, the independent variable is H. The dependent is M because depending on how many hours you work, you will make this amount of money, right? Okay. For this one, the independent is S. That's the number of shells. The dependent is B, the number of books. Number 7, independent is H, the number of hours. Dependent is pages. Independent is M. Dependent is G. Independent is X. Dependent is Y. Independent is R. Dependent is H. And then for this last one, name at least 2 independent variables that could result in a change in a monthly electric bill. A, the amount of electricity used, and C, the cost of the electricity. Okay. All right. That is it for today. I hope that made sense. I think the independent-dependent thing can get a little bit jumbled in your brain. Don't panic. We're going to keep practicing with it, and it will make more sense if you're struggling with it now. Maybe you're not, but if you are, don't worry about it. All right? Feel free to leave me questions in the comments below or email them to me, or you can save them for when we meet in our small groups. Good job, you guys. Bye.